And this, let me say it again, this is going to lead us into geometric proofs, which is the same thing as algebraic, but we're adding in segments. We're still going to use some of the same properties that we did, and I'm not going to talk over you. If you are going to interrupt me, you're going to be gone. Does everyone understand? Now, the first one says that Q is between P and R, so it's a segment. Let's draw a segment. What are the endpoints of that segment? P and R, because it says Q is between them. Now, where does that mean I need to put Q? Now, does it have to necessarily be right in the middle? No, I could put it down here. Now, what do we know about these things? These are your notes that you need to be able to pass class. Okay, what do we know about this segment PQ and this segment QR? They do equal up to the whole thing. Take a point. So if you add PQ plus QR, that gives you PR. Can anybody tell me why? It's our first postulate that we did together. Yes, but it's the first postulate we did ever. We had a whole worksheet on it, and it starts with an S. What are we adding together? And then we're adding, so it's the segment addition postulate. Take a point. That was a struggle, and it shouldn't have been. So this worksheet, the reason we're filling it out this way is because it's going to help us with our proofs. Addition postulate. Alright, so then the second one says that Q is the midpoint of PR. So we need to draw a segment. What are the endpoints? P and R. Now, if it says it's the midpoint, where does it need to go? It has to go in the middle. I don't know if that necessarily warrants a point. Now, what does that mean if it's the midpoint? Not just that it's in the middle. What does that mean?
It's half.
It's half. So what does that mean? Y'all, Lord Jesus, I said not in the middle, and I know it's half. What does that mean about my segments? They're the same. Take a point. So what could we write? Oh. PQ equals QR, and we could also say that segment PQ is congruent to segment QR. So when it has the segment line, you use congruent. When it's just the length, you use equal. This symbol is congruent. I don't even know what words those were.
Is that an X right there?
Right here?
Yeah.
What is this letter?
That's an X right there. That's an X right there.
Look at your paper.
Well, Raven.
Don't come to college.
Oh, okay.
Definition of midpoint. I don't know why I put a period after of, but it doesn't need one because that's the whole word. So this says that segment AB is congruent to segment CD. We can also say that the length of AB is equal to the length of CD, and that is the definition of congruence or congruency or whatever makes your soul happy. That's it. That's all you have to do. So when we have a proof and it gives you this, you then say that the lengths are equal to each other by that definition. And then you can plug in numbers. And it's amazing. Is there a reason that you keep talking? No. You see how no one else is? Because we're trying to have a lesson. Alright, so this says that segment AB is congruent to segment CD, and segment CD is congruent to segment EF. So who thinks they know what we can say about those two things? Grace? AB is congruent to EF. Why? What property is that, y'all?
That is some
Transitive.
I don't even know what that was. Transitive, yes, take a point. Grace, you get a point as well. Transitive property. So remember, transitive property is when you take out the parts that are the same and put everything else together. It moves around like a transit. Isn't it crazy? It's not. It's really self-explanatory. We are not friends anymore. Just to let you know. Okay, we'll see how your grade reflects when we're not friends anymore. R is the interior of angle PQS. So what does interior mean? Inside. So let's draw angle PQS. Can anybody tell me what the vertex is going to be of this angle? It's Q, because the middle letter is the vertex. Whoever said Q, take a point. You did not say Q, Ms. Arrow. Now, PQS is our angle, and it says that R is the interior. So that means I'm going to put R on the inside. What do you think I could do with Q and R? I could make a ray. No, because you were just saying everything. Now, it doesn't say that R cuts it in half. It does not say that ray QR cuts it in half. But what do we know about PQR and RQS? No, we don't know that they're congruent. No, guys. We could add them together and make it equal the whole thing, right? These are not congruent because it doesn't tell us that it bisects. But we can say that, let me think of how I want to write this. The measure of angle PQR plus the measure of angle RQS equals, interrupt me one more time. One more time. PQS. Now, if when we added the segments together, it was the segment addition postulate, what do you think this would be? Oh my God, really? What are we adding together? The angle addition postulate. Take a point. The rest of you deserve to lose a point for that. Wake up. Oh, tater tot. Alright, now, for the next one, what does bisect mean?
You cut it in half.
You cut it in half. So let's draw angle CAD. What is the vertex of this angle? A, because that's the middle letter. And it says that AB bisects, so we need to draw it directly in the middle. Choo! Yes, now we're getting technical. So if they're, pardon? Alright, if it cuts it in half, that means that this one is congruent to this one. So if they're congruent, you put little half moons. And we'll say that the measure of angle CAB equals the measure of angle BAD. And why are they congruent? Why do they equal each other? Because it bisects it. Yeah, it goes right in the middle. So this is the definition. I'm so glad y'all can read, but can we write too? Of angle bisector. Why did we put the half moons on it? And what does bisect mean? Okay. Alright, angle 1 and angle 2 are complementary. What does the word complementary mean? Adds up to 90. So that means that the measure of angle 1 plus the measure of angle 2 would equal 90. Thank you. Definition of complementary. And it's not complementary. Please don't say that. Angles. Why?
Can you go back to the artist interior pieces? Because that's just like switch on that.
It's right there.
Oh.
Bow battens. It's French. Are you ready now? You fixed it? So you're not ready because you're still writing? Okay. Linear pair. What does that mean if they're a linear pair? They add up to 180 and they make a. So it would look like this. 1, 2. And we would say that the measure of angle 1 plus the measure of angle 2 equals 180. Definition of linear pairs. Dun dun dun. We're almost done and we can start our proof. And if we get it done, then you won't have any homework. Alright, what kind of angles are 1 and 2 on the next one? Vertical! And what do we know about vertical angles? They are congruent. So we would say that angle 1 is congruent to angle 2. And that's the definition of vertical angles. This? With a squiggy? That means congruent. Yep. Okay. Now, if angle 1 is congruent to angle 2, this is just like with the segments. What else could we say? Pardon? The measure of angle 1 equals the measure of angle 2. This M means measure. It's not just a letter hanging out with it. Please don't divide by M. That means the measure. And that's the definition of congruence. For 2 whole points. Can anybody tell me what this symbol means? Perpendicular. Take 2 points.
I said that.
No, you didn't. You have a very distinctive voice. So, what does it mean if 2 lines are perpendicular? Let's draw this. I will take it away. Okay. What does it mean if they're perpendicular? No. They are right angles. Hallelujah. Take a point. No. No. So these two are perpendicular to each other. They intersect right here at E. Can anybody tell me what that means for the measure of angle AED? What is the measure of that angle? 90 degrees. Fantastic. Can anybody tell me what symbol we use if it's 90? And what we put right here? A little square. Take a point. And this is the definition of perpendicular lines or segments, arrays, etc., etc. Alright, so if angle AED is a right angle, then that means that AB is perpendicular to CD. It's using this drawing. And that is the definition of right angles. Chum chum. If we can finish this first proof on the next page, then we don't have homework. Do you think we can do it? I don't want to bet. I just want us to do it. Why are we betting? Why is that a new thing?
But it's like saying okay.
It's not. It's not. Okay is like saying okay.
It's like
Who's our?
our generation. Up to
Can we wait just a minute? Because we're going to use it for this, and then we can. Alright, so at the top of this page, it says segment addition. That's what we're going to be talking about. Two basic postulates for working with segments and lengths are the ruler postulate, which gives us our number line. If you didn't know that, now you know. And what's the other one that goes with segments? We just wrote it down.
what?
Thank you. Take a point. Segment addition postulate. Which describes what it means for one point to be between two other points. I'm just finishing the sentence. Y'all read the sentence. It just says the segment addition postulate, which describes what it means for one point to be between two other points. It's just telling you what the segment addition postulate is. What is happening?
I didn't know what you were reading.
Alright, the ruler postulate says the points on any line or line segment can be put into one-to-one correspondence with real numbers. It's just this. That's a lot of fancy nonsense for 1, 2, 3, 4, 5. Now the segment addition postulate says that if we add up the parts, we get the whole thing. What is this property? Reflexive. Take a point. Can you tell me what the next property is? No. Symmetric. Take a point. You did. I heard you. For so many reasons. You're like a superstar over there. A super special star. Yes. Okay. Alright. This one. That is transitive. Take a point. So this says to use the segment addition postulate to prove this. Alright, so we're trying to prove that if AB is congruent to CD, then AC is congruent to BD. So we know that these two things right here are congruent. The tick marks mean that they're congruent. Put the tick marks. Thank you. Alright, so we are given that AB is congruent to CD. And it says given. So definition of congruent segments means that we would write what next? What did we write right here? Definition of congruence, we went from this to? Okay, so we would just say AB equals CD. Dun 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 dun.
I'm on number 3.
What is number 3?
That is.
Reflexive? Yes, that is the reflexive property. Okay, can anybody tell me what we would put together for the segment addition postulate? AB plus BC. AB plus BC equals AC. Yes. Okay. Now, let's talk about why we do that. We started with AB equals CD because we just said that this was by the definition of congruent segments. Then we said that BC is equal to BC, right? Now, what we're trying to do is we're trying to put these two together to get this segment because we're trying to prove that this guy is the same thing as this guy. That's what we're trying to prove. So we need to use this part to get to the whole thing. Now this says that CD plus BC equals AC. Why? What did they replace? They replaced AB, right? And why did we replace that? What did we use? If you plug stuff in, what property is that? Substitution. Good. Okay, then what did they do? They didn't use substitution. Segment addition postulate again. Now, the reason we know that they use segment addition postulate again is because they added the rest of our segment up right here. They did this guy plus this guy to get the whole thing. Alright, now they said, do we see how these two are the same thing? So then they said that AC equals BD by the transitive property. So how could we go from this to this? If we can go from here to here by the definition of congruence, can't we go backwards? Okay, so what is that? Definition of congruence. And we could say definition of congruent segments for fun. Now, geometric proofs are not as straightforward as our algebraic ones. You have to actually think, and heaven help some of us, but I feel like we can do this. Okay? Now, we're going to glue this into our notebook. Please go to page 14A in your notebook. Am I still talking? Yes. Alright, go to 14A. It looks like this. Flip it over. 15A is going to be on the left. And 15B is going to be on the right. Now, the first one that we're going to glue down, yes, is that one, the first one that we did. This goes on the left. That way we can use it all the time. Yes. Am I ever scared? Yes.
Are you independent?
Am I independent? Yes. I have my own house. I have my own car. I work hard, 2 jobs. I'm a bad broad. If only you knew how well I can rap. Adios, hasta lunes. No homework. Sit down. No, seniors can leave. Hey. Do you have a pass? No. No.